Hello everybody. In this video, we'll present the new features of STRAP 2020. The first major feature is a slab element. The slab element allows the user to define a slab by selecting the slab contour. Element meshing and the connection between the slab and other elements, such as columns, walls, or beams, are done automatically. The big advantage of the slab element is that the slab element is updated with any change in the model geometry. Let's see an example. From the side menu, click Slab and select Define. At the Slab Definition dialog, the user may define or assign the slab property. For this example, we'll define a uniform thickness of 25 centimeters. The user may define the slab as rigid in plane. Set the parameters regarding the mesh density. Select to define a new slab by selecting the slab contour, or convert existing elements to a slab element. If the slab is a part of a submodel, the user must determine the connection type between the slab and the supported columns or walls. To define the slab element, we'll select nodes along the slab contour. We can see the slab defined within the contour. The delete command will allow the user to delete an existing slab or to convert the slab to elements. The revise command will allow the user to revise the slab contour or add holes. The releases command allows the user to define moment release along a slab edge. The show mesh command allows the user to see the internal mesh elements of the slab. Let's see an example that will show the advantages of a slab element. Let's say that we want to move the location of the frame 1.5 meters in the -x2 direction. We'll use the Move Nodes command. Now we can check the internal mesh of the slab. We can see that the program regenerated the internal mesh and extended the beams that are connected to the columns. For the second example, we'll add a wall segment. We can see the revised wall section, and if we look into the internal mesh, we can see that the program automatically regenerated the mesh and connected the slab to the wall. Data for slab element can be displayed. We can see the slab level, the area, the thickness, the defined nodes, and the attached nodes. Information table is also available. In the Loads module, an option for slab load is added. Uniform temperature and self-weight are available. For uniform load, the load direction can be perpendicular to the slab or in one of the global directions. For this example, let's define a uniform load of 1.5 ton per square meter in the -x3 direction. The load is displayed by a contour line along the slab contour. Under Setup, Miscellaneous, a new tab called Screen Graphics is added. This tab allows the user to set the screen text size and font, the size of the restraints, and the releases. Selection size mark and the option to display lines and text with dithering. Under Setup Colors, User Colors is added. This option allows the user to assign any color to the selected option. Additionally, predefined setup is also added. This option allows the user to select a predefined color set. For example, if we select a black background, all the colors of the interface are revised. The Properties dialog provides a drawing of the selected sections, as well as section dimensions and local axis orientation. When defining a new property from one of the steel tables, STRAP will present a drawing of the section and the section properties. A section drawing is also added to the section property table. Under Beams Split, we added a new option for splitting beams to a given number of equal beams. For this example, we'll split a column to 5 equal parts. We can see that the program created 5 equal members. Additionally, we added an option to unify collinear beams. Now, we'll unify the column to one member. Under Beams Offset, the definition of an offset measurement can be defined by picking 2 nodes. For example, we'll set the x2 measurement by picking 2 nodes. A new option for element result axis is added. We'll present it within an example. As a default, the element result axes are parallel to the global axis. X is parallel to x1 and y is parallel to x2. Under Change Elements Result System, we added an option y is towards a selected node. We'll select a node in the center of the cylinder and select all elements. We can see that all of the elements' result system is rotated, and now the y-axis is towards the center of the cylinder. The following feature regarding load combination will be presented by an example. For the following model, 3 load cases are defined. The first load is assigned to construction stage called construction, and the dead and live loads are assigned to the whole model. We will define a new combination with the option Solve as a load case. Insert the load factors and solve the model. After solving, at the Results module, we'll open the combination table for the definition of combinations after solution. We can see the original load cases, but we can't see the load case that was defined with combination Solve as a load case. To display this load case, we'll go to Combinations, define Revise Groups. And select Group of Combinations. Click OK and include the load case. Now, the load case will be available for combinations after solution. Usually this option is needed when the model includes stage construction, and nonlinear elements such as unidirectional springs, compression tension only beams, nonlinear cable elements, etc. At the Results module, under column Wall Result at Level, an option to display only axial force is added. Also in the Results module, right-click, Data for Node is now available. In concrete design, for 2D slabs, where columns and walls are presented by restraints, the restraints can be displayed on the slab detailing drawing. For concrete beam design, under Defaults Reinforcement, we added an option to multiply the positive moment by a factor. For beams detailed results and beam detailing, the support names are the column names. We can see it at the detailed results and at the beam detailing. For concrete walls design, under Defaults Seismic, we added an option to multiply the moments from earthquake loads by a factor. This option is also available under Parameters Seismic for selected walls. Under Data Display Capacity Parameters, we added an option to display the shear capacity. We can see the shear capacity for each shear design unit. The name of the prestressed concrete module is revised from post-end to prestress. For this module, we added an option to design of pre-tensioned beams. While defining a pre-tensioned strands, the user may define debonding or deflection of the strands. Additionally, we added a calculation for development length. Under Display Table Summary of Losses, we can see the loss of force due to the calculated development length. At the Dynamics tab, under Display Table Display Model Results, we added a drawing of the defined response spectrum. Additionally, we can see the position of each mode at the response spectrum. In AutoStrap software, under Loads, Slab Loads, we added an option to define self-weight factor. In this example, we'll define 1 ton per square meter dead load, 0.15 ton per square meter live load, and a factor of 1 for self-weight. The self-weight will be included in the dead load after exporting the model to STRAP or BeamD. This option is available for uniform beam loads as well. Under File Setup, we added a BeamD tab. Clicking Edit Parameters will allow the user to define the parameters for longitudinal reinforcement, shear reinforcement, and deflection.
Thank you very much for watching.